Related rates. How to solve related rate problems. That's what we're going to learn in this section. This is basically an application to derivatives. Where do we use derivatives in real life applications? And all the stuff we're going to be doing today falls under something called related rates. When we talk about rates, we're talking about a rate of change, let's say like dv dt, dx dy, dy dx, d something else. So most of these questions are going to be word problems. So you need to really read the problem carefully and identify all the quantities you can get out of it and tell, is it increasing or decreasing? If something is increasing, that means the rate of change is positive. Like it's a positive, or dv dt is positive 5. It's decreasing, then the rate of change is in the negative. So dv dt is negative something, maybe negative 5 something. So that's the first thing. Like, maybe underline the important things, write down the given, the numbers, identify the quantities, write them down, keeping in mind if it's increasing it's a positive, decreasing is negative. Then assign variables to the quantities that we have, no matter what kind of quantities there are. They talk about volumes, surface areas, anything, side length. You assign variables to those. It could be like a triangle and you're assigning the size of the triangle. From there, you can set up an equation. And that equation can come either by using either like the Pythagorean Theorem or some area formula or surface area formula, area or surface area. Could be a volume formula that I will list down at the end to summarize them. Sometimes similar triangles, maybe we need to set up a proportion here from similar triangles. Or it could be a formula that's coming from chemistry or physics. And in this specific section, to make things easier for us, we're going to assume that all the variables are as a function, can be written as a function of t. And the procedure here is, after we set up the equation, we need to differentiate that equation. Differentiate this equation with respect to time. This is going to be d something dt. And this usually involves implicit differentiation. Then after we do implicit differentiation, we substitute and solve. Let's look at the easy example, no word problem example first. This one. Write it down. If you like to start working on it, you're welcome to do so. We can go over it now. They want us to find dz dt. They already give us the equation z squared equals x squared plus y squared. So what do we do here? We differentiate both sides with respect to t. So what do we get? 2z dz dt. 2x dx dt. 2y dy dt. And we can cancel the 2's, right? And let's see what is given. I need dz dt. I don't know what that is. I don't know what z is either. So, but I can go back to the equation z squared equals x squared plus y squared and calculate what z is by substituting x5 and this is 12. So z squared would be 13 squared. So in this case, we are going to substitute z to be plus or minus. Don't forget the plus or minus 13. Plus or minus 13. So plus or minus 13 dz dt. X is 5. dx dt is 2. Y is 12. And this one is given dy dt 3. So plus or minus 13 dz dt. 10 plus 36, which is 46. So then dz dt is 46 divided by plus or minus 13. We may move on now to a word problem. So if you look at this one, So this is a spherical balloon, radius r. They give us the volume, not volume, that's dV dt. As you can see from the units, 20 inches cubed per minute. How fast is the radius of the balloon is increasing? What is dr dt when the radius is 6 inches? So there's dr and dv. So v means the volume of the sphere. So the formula for the volume of the sphere is 4 over 3 pi r cubed. Pi r cubed, 4 over 3 pi r cubed. So if we differentiate with respect to t, we get dv dt. Keep this constant, bring the 3 down, r squared dr dt. The 3 cancel each other. dV dt is 4 pi, r is 6 square. dr dt, we're looking for that. But they give me dV dt, so I can substitute it in as 20. Divide both sides by 4 pi and 6 square. And this is by 4 1 by 4 5, so 5 over 36 pi equals dr dt. And then with simplifying this, that gives me dr dt. So notice r, radius is in inches, and t in time, in minutes. So dr dt is about 0.0442 inches per minute. So dV dt is negative 20 because it's losing water, so that's why it's decreasing. It says how fast is the depth of the water decreasing when the water is at exactly 16 feet deep. So how do you start with this one? I see V and I see H, height and stuff. So I need to find the volume for this. What's the volume of the cone? It has a formula, 1/3 pi r squared times the height. Then if we differentiate both sides, we are going to have two variables, one r and one h. One of them r, one h. But we can't work with two variables. We need to have only one variable. So what do we do in this case? We need a relation between r and h. R and h. And this is where we use similar triangles for. ABC and ADE are similar. This sign means similar. And I don't know if you remember similarity, how you set up proportion from similar. So you say this side to this side equal this one to the whole thing. R to 10 is H to 24. From here you can solve for R. I don't want the R. Why I don't want the R? Because they give me dH dt. They didn't give me dr dt. So I want to get rid of the R by solving for R in terms of H. So R equals 5H over 12. 5H over 12. So now, from the volume formula, 1/3 pi r squared times the height, I substituted r equals 5h over 12. And I squared it. And I simplified. And now it's ready to be differentiated. So now we differentiate both sides with respect to t. We get dV dt is the 25 pi over 3 times 144, all of that constant, just keep it as is, times 3h squared dH dt. Now the 3 cancel each other. Let's see what they give us. They want dH dt. Well, they give me the height. The height is at 16. And they give me dV dt, which is negative 20. So it's a matter of a substitution here. You substitute and you solve for dH dt. And that would give me negative 0.1143. We have another example. Two sides of a triangle have lengths 4 meters and 5 meters. The angle between them is increasing at a rate of 0.06 radians per second. Find the rate at which the area of the triangle is increasing when the angle between the sides of fixed length is pi over 3. Start by drawing a diagram. Draw a diagram. Label the given information on the diagram, please. Write down what is given. Write down what is missing. So what do we do here? After you sketch the figure, the 4, 5, they give us the side that I call the angle theta between the two given sides. D theta dt is given. It says it's the rate, and radians for angle and second for time. Find which the angle or the area, which is dA dt, when theta is pi over 3. When theta is pi over 3. Since they want us to find dA dt, first thing you want to find a formula for the area. Formula for the area, so you can differentiate it. So how do you start with the formula for the area? We know the formula for the area of the triangle is 1/2 base times height. The base is 5 and the height h. How do I find the height? Well, if you use sine theta, if you want to get theta involved, because d theta dt is given. So on the right side, as you can see, we can find sine theta. What is sine theta? Let me check. Sine theta is the opposite over the hypotenuse. So then the height is 4 sine theta. The height is 4 sine theta. Then you substitute this in there to get 1/2 times 5 times 4 sine theta. That's 10 sine theta. So now A equals 10 sine theta. We can differentiate both sides. dA dt equals 10 derivative of sine theta d theta dt. Notice they give us theta, pi over 3. They give us d theta dt. We can just substitute them in and solve. When you put that in the calculator, make sure the mode is in radians. You got 0.3 meters square per second, because time is for second and the area is meters square. Now we recall the formulas for the volumes of different figures. The volume of the cylinder, the formula for that is pi r squared times the height. For the cone is 1/3 pi r squared times the height. For the sphere is 4/3 pi r cubed. For rectangular prism is the area of the base times the height. The area of the base times the height. In a lot of cases, sometimes they give you the formula within the problem. Like they tell you the formula for the volume or surface area, they give it to you 90% of the time. Next thing is the Pythagorean theorem. Make sure you know the Pythagorean theorem. And similar triangles. If BC parallel to DE, then AB to AD is equal to AC over AE equals BC over DE.